This is Dr. Carroll with another Advanced Data Structures video about overloaded operators. So let's say you wanted to declare two instantiations of a class DNA, and let's say mutant DNA and my DNA. We won't get into the biology of that. And let's say you wanted to write something very simple and elegant like mutant DNA equals my DNA. Again, let's just overlook the biology of that. How would you do that? Well, the answer is you would add an equals equals operator to the DNA class and make sure all the data members are the same. And it'd be something like it'd be equivalent to an is equals method. The problem is we already have an equals equals operator that exists in C++. What we need to do is overload it. Okay? Let me give some examples that you're already familiar with. Let's see here. So let's talk about the addition operator. So we can do math, right, on an integer. 1 and 2, we can add two integers, and we would expect to get a third integer. Oh, shoot, we can even do doubles. You take 4.4 and 5.5 and do a third double. So notice that this operator takes both an int, and it can also figure out how to take a double and double. We've overloaded it. Now let's go to a more complex example, to a non-primitive data type. Here we have string, which is not included in C++, but we have to do a pound include string to get it. And so we have username plus, so username here is a string. This is a string literal, and then another concatenation, or the addition operator, for whatever this returns, which would be a string, with another string. And we can assign that to a string here. Notice we're also, okay, so there's another example of overloading an operator that you're very familiar with. So let's talk about the syntax for overloading operators. We need to have a return type, just like any method would. And then we have the keyword operator. And then we provide the operator we're going to overload, whether it's plus, whether it's equals equals, whether it's insertion operator. And generally there's not a space between there, but operator to overload looked funny, so added a space. But usually you don't see a space there. And then you provide the parameter list, and then you provide the function as normal. So let's talk about an example. Okay, so back to the DNA class. In the .h file, we would provide a definition in the public section, and we would have something like this: Boolean operator equals equals, and then we provide the parameter list. Const, a type of our object, DNA, and then right-hand side, RHS, a very common abbreviation for overloaded operators. And this method is not going to modify any of the data members, so we can make it const. Now, operator equals equals is the name of the method. It looks a little weird, but it's the name of the method. Okay, and so that's what we do, and then we provide the implementation. Let's say we wanted a deep copy, but we didn't want to use the copy constructor. What could we do? Deep copy without the copy constructor. We could do a DNA reference, we'll get back to that in a second, operator equals const DNA right-hand side, and then we would provide the rest of it. Let's go ahead and do that just so that we can see a more full example and give us some exposure to some other topics. So first we'd want to check to make sure that we don't have a DNA object on the left, an equal sign, and then a DNA object on the right. So we need to guard against self-assignment. So what we'd do is we'd use the this keyword, which is a pointer to the object itself, and we'd look at its address, because it's a pointer, against the address of what's on the right-hand side by using the address of operator, And I've left the assignment of all data members to the interested student. Now we return the this pointer dereferenced so that it follows the conventions of C++. Okay. Now let's talk about some rules. There are some rules here, for example, that you cannot overload certain operators. It just makes life very, very confusing. The scope resolution operator, the member of operator, the dot star operator, and the conditional operator. Other than that, it's fair game. There's some more rules, as you might have guessed, that we need to follow. You can't overload operators that are you can't overload operators that aren't already in C++. You can't just invent a new operator. You can't change the standard precedence of operators. At least one operand of the overloaded operator must be an instance of a class. So either the left-hand side or the right-hand side. The left-hand side needs to be, but the other one could be a primitive type, or it could be another instance of the class. It's very common to overload the assignment operator, the equality operator, the inequality operator, the relational operators, and you can't change the number of arguments of an overloaded method. Okay, so that's the rules and some guidance. So let's talk about another example. So we probably maybe have even written lines like this, maybe not C out, maybe C in. So can we do something like this, my DNA? Sure. We just need to add an operator, insertion operator, to the DNA class. Then, and by the way, that would be the same as calling using the more full name. It'd be the same as this, okay? The operator, insertion operator, passing in my DNA, okay? Same as, okay? Uh-oh, we've got a problem here. Did we write this class? Can we edit this class? No, we're not really interested in modifying the OStream class, and so we don't want to do that. What we need to do is talk about another rule. Let me paste it up here with the rules. Given an operator, we'll just call it X. So we're working with the X operator. That could be addition, equality, insertion operator. And you have A, operator B, where A and B are instances of classes. If the overloaded operator is a function member of the A class, it's the same as doing A member of operator X passing in B. Otherwise, if it's not a member of that class, then we have a different notation. Then we have the notation operator X passing in A and B, which is nice because then it gets us around the necessity to modify the A class. Okay, so let's talk about that. So for overloading the insertion operator, we would have return type operator, insertion operator, and then the one on the left would be an OStream parameter, and then we'd have some other class parameter. Okay, let's fill the details in a little bit. So we'd have the OStream operator that would look like this. We want to pass a reference to it, and that's not just a nicety, it's a necessity. And then the other class, we're going to make it const, and then we're just being generic here, a reference to the other class, and we'll call it right-hand side. So what about the return type? Okay, let's think back to this statement here. What do we have? We had cout, insertion operator, myint. Well, let's just ignore the rest of that. We could put parentheses around and say, oh, okay, that's going to occur first. What we need is we need this statement to evaluate to a statement that looks like this: see out my double. So then what does this need to return when it's done? It needs to return a reference to see out, the OStream operator. That's the same thing we're going to have here. OStream reference. This needs, when we call the insertion operator, this needs to return the OStream, a reference to the OStream operator. Okay? All right. If you think about it, we need to, because we very well could have the occasion that we wanted to do my DNA and then we wanted mutant DNA right after it. So then when we were done with this, what's highlighted would need to evaluate to see out. Okay? All right. So for the DNA example, we could have something equivalent to this. OStream operator less than, OStream out, a constant reference to a DNA object. We're calling it DNA. We'll just call DNA print to make it easy. And then what would we do with the return? We need to return that reference. It needs to be a reference so that these match up. And we return it so that this evaluates to see out. If you want to have in this method, oh, and notice, do not make it in the DNA class. It is not a member function of the DNA class. If we want access to the private data members, we need to declare the method as a friend. If we want to do something like we need to do DNA.id, then we would need it to be a friend class.